So, first thing is vocabulary, parts of a polynomial. So this chapter is called polynomials. We've seen some polynomials. They were called quadratics. Now we're going to move on to bigger polynomials, okay? So the first thing is some definitions. So look at, mine's color coded, but yours, I know yours isn't, but you can just look up here. Coefficient. Coefficient, which numbers is coefficient pointing to? The 4 and the 5, right? The 4 and the 5. Those are coefficients. 4 and 5 are coefficients, but it's not pointing to the -2. Why not? Exactly, because -2 doesn't have a variable with it. -2 does not have a variable with it. That's why we call it a constant. A constant means it's just by itself. Okay? So the -2 is a constant. The 4 and the 5 are what we call coefficients. And they didn't put this on there, but I'm going to add it. Actually, the 4 is not just a coefficient. It's what we call the leading coefficient. Leading coefficient. It is a coefficient, but it's got a more specific name, leading coefficient. The reason it's the leading coefficient is because it's in front and it has the big power, right? 3 is the big power. 3 is the power that rules. It's the biggest power. So whoever has that is the leading coefficient. Okay, 5 doesn't have that. 5 only has squared, only has 2. So whoever has that is the leading coefficient. Okay? And then we talk about degree. We've talked about degrees before, but degrees is going to be huge this chapter. Degrees are the greatest exponent. The greatest exponent here is 3. So we call this one a cubic. It's a polynomial, but it's got a more specific name. So anything with cubed to the 3rd power, if that's the degree, we call it cubic. We don't have this on here, but if anything was to the 4th power, we would call it quartic. Like quart, right? A quart of milk. The reason we call it a quart is because 4 of those make a gallon. Okay? So 4 quarters make $1. That's why you see the QUAR. 5, anything to the 5th power. If 5th power is the highest, we would call it a quintic. Okay, quintic. Okay. Those are the ones we haven't seen before. Cubic, quartic, quintic. The ones we have seen before are the ones I skipped. X to the 0 power is called a constant. On our example, we have a constant. What's the constant on our example? -2, right? So I don't understand. It doesn't have an x. So why is it called a constant? Because it actually does have an x. We just don't write it. It actually, this guy right here actually has one of these that we don't write. It actually has that we don't write. The reason we do not write that is because, let me go over here for a second. Anything to the 0 power is always going to be just +1. Anything to the 0 power is equal to +1. Anything you can think of, the biggest number you can think of. One of my classes didn't believe me, so I showed them this. Oops, it's not there anymore. They chose -845. That was the number they chose. And I was like, okay, to the 0 power. The answer is always going to be +1. The ugliest, craziest number you can think of, it's always going to be +1. Okay? Anything to the 0 power. Yeah, decimals too, watch. Let's see. Let's change this guy to 8.6. Okay. You want to know why that's true? Because a lot of people are like, no, I don't believe it. This is why it's true. You don't have to write this down, but it's just it's a little pattern. Math's all about patterns. So let's pick a little number, like 2. What's 2 to the first power? 2, just the 2, right? What's 2 squared? 4. What's 2 to the third power? Don't say 6, not 6. 2 times 2 times 2 is 8. What's 2 to the fourth power? 16, yeah. What am I doing to get down the list? Multiplying by 2, right? Okay. So how do I get up the list? If I'm going down the list by multiplying by 2, how am I getting up the list? Dividing by 2, right? So the guy that comes before this should be this guy, right? So what would fit the pattern? What number here would fit the pattern? It has to be a 1. Can't be 0. A lot of people say, oh, it's 0. 2 to the 0 power's got a 0. It's 0. It doesn't fit the pattern. It has to fit the pattern. If it doesn't fit the pattern, it doesn't work. Math's all about patterns, right? That's why I became a math teacher. Math teacher because math has patterns. English language does not have patterns. English language, if anyone learns the English language, if you've never, like, sometimes you don't grow up speaking English, so you have to learn English. And talk to anybody who's ever learned how to speak English. It's the hardest language there is. It's harder than Spanish, harder than French, harder than anything, because it has a lot of rules, but not all the rules. Like, it's like there's always like, yeah, this is the rule, except there's a lot of those in English language. So English language is very hard to learn. My son is learning how to read, and he'll read a word, and then I'll tell him, I'm like, no. I'm like, no, that's not how you say the word. He's like, yeah, but that's the rule though. And I'm like, yeah, but there's an exception to the rule, right? The English language, there's always exceptions to the rules. That's why I hate English. English was my worst subject. That's why I didn't become an English teacher. Math, there's no exceptions. Math, there's always rules. If you know the rule, you're good. If you don't know the rule, then learn the rule. Okay? In math, for this guy, we're multiplying by 2. To go up the list, we're dividing by 2. So that's why it works. 1 times 2 times 2 times 2 times 2. Division. Divide by 2, divide by 2, divide by 2, divide by 2. Right? In math, there's no, yeah, that's the rule except when, that's, in math, it's just, it is or it isn't. Okay? So that's why anything to the 0 power has to be 1. Okay? All right, so that's kind of a tangent, but let's go to this. Let's go back. So we don't write that. We don't write that here. Like, you never see this tag here. You never see this little x to the 0 power, because why? It's just 1. All right? You don't need it. Okay? Okay, so next one. X to the first power. X to the first power is called linear. That was our first chapter. Our first chapter dealt with constants and linear. We took a quiz on it back in August. The chapter we just covered, the name of the chapter was quadratics, because it had a lot of x to the second power, x to the second power, x to the second power. If I look on your paper here, I'm going to find a lot of x to the second powers. That's the degree. That's the greatest exponent, right? Okay. So on Monday, they're going to give you something like this. They're going to say, this guy right here, 4x to the fifth plus 2x to the third minus 8x plus 5. And they're going to say, which one is that? Is that quintic? Is it quartic? Is it cubic? Is it quadratic? Is it linear? Or is it constant? Well, it has a lot of them. This one is constant. This one is linear. This one is cubic. This one is quintic. So which one is it? The greatest power. We only look at the greatest power. We only look at the greatest power. The people we focus on are the ones who are in power. That's like life, right? If you want to become someone who gets focused on, get power, right? That's the ones who with power rule, right? Just like that's like same like in math. Okay, that's why you go to school, so you can one day become those people, become the shot callers. Okay. Um, so here's a matching. We're going to use these guys to match. Okay. So they only go in one spot. Okay. So let's start with this guy right here. Negative 2x minus 7. Is that a coefficient? It has a coefficient, but it's not, right? Which one is it? Say your name. It is a binomial. Yeah, it's got two terms. So we're going to write it over here. Negative 2x minus 7, and then I'm going to cross it out. Okay. Next one. 5x. So if it said the 5, it only said the 5, I would say coefficient. But it's not. It's the whole thing. So it's going to be a monomial. Yeah, it's by itself. It's a monomial. One term. Yeah, if it said focus on just the 5, absolutely, that's a coefficient. That's a leading coefficient, actually. Okay, the next one. 2x to the 5th minus x cubed minus 4x squared plus x. That one's going to be a polynomial, right? It's got a lot of terms. So that one's a polynomial. The next one, negative 3x squared plus 6x minus 9. One you've seen before. That one should look familiar. You've seen that one before in notes and homework. And so which one is that? Yep, it's a trinomial. Because there's 3 terms, so it's called a trinomial. The next one only wants you to say the 7. Only the 7 in 7x plus 2. So it doesn't want you to focus on the 2 or the x, just the 7. So what is that 7 called? Even more than that. Leading coefficient, because that one has the power, right? X has the power. X is the highest power. So 7 in 7x plus 2. Now the negative 5 in 8x squared minus 5x plus 3. That one's just a coefficient. That one's just a coefficient. Could be a negative, could be a positive. Oops, no. 8x squared minus 5x plus 3. So the only one that's left is a constant, 9. Yeah, 9 is a constant in that guy. 9 is the constant because it's all by itself. It has no x. If it's all by itself with nothing with it, it's called a constant. Could be positive, could be negative. Okay, so that's the vocabulary. That's important because on the test, on the homework, on the classwork, on the quizzes, you're going to see these words. You're going to be like, Mr. Flores, what does that mean? What does constant mean? Check your notes. Okay? Mm-hmm. Yeah. Uh-huh. So the 5, right? The 5 is definitely negative 5. Sorry, negative 5. It's definitely a coefficient because it's in front of a letter, right? But does -5 have the most power? No, 8 does. So 8 is the leading coefficient, yeah. This guy here, the 7, that has the most power. 2 doesn't have any powers. 2 has 0 powers. X has at least 1 power. So if the number in front of the most power, if that's the one with the most power, then it's a leading coefficient. Like over here. The one with the most power is 5. What's the number in front of that? That's 4 is the leading coefficient. -8 is still a coefficient, but it doesn't have all the power. So it's just the coefficient. 2 would also be a coefficient, yeah. 5 wouldn't, it would be a constant. Good. All right, so now let's get to the backside or the inside. Okay. You're going to see a lot of this. Perform the operation. You're not doctors, so you don't have to perform an operation. But in math, we have 4 operations. Addition, subtraction, multiplication, and division, right? Well, you're lucky. Today, we don't have to worry about division, so it's only 3. We're only going to focus on 3. Add, subtract, multiply. Okay? So let's look at number 1. How do I get rid of the parentheses? So let's distribute. That's multiplication, right? All right, so the first set of this parentheses. What's in front of there that I have to, a +1, right? So I'm going to distribute a +1, multiply. It's going to stay the same. Okay. When I distribute to the next set of parentheses, what do I get? Exactly. It's a -1 in front of there. So that means the sign's going to change, right? So it's going to be +2x squared, +4x minus 7. So we did multiplication so far. Now, what do you think we're going to do now? Combine like terms. Combine like terms means add and subtract. Add and subtract. When I add and subtract, I'm not collecting powers. So what do I mean by that? Well, these guys are like terms, right? I'm not collecting powers. So it's not x to the 4th. I'm just adding their coefficients. So -3 plus 2. Then they're not like terms. Yeah, if they don't have the same power, they're not like terms. Like the first, like these two guys, like right here, like -3x squared and -9x. Those are close, but they're not like terms. So I can't do anything with those guys. Okay, so next one. -9, +4. So -5x. And then the constants by themselves. Yep, -2. And then you don't need that -1 in front. You can write it if you want, but you don't need to write it. It's up to you. Either one's okay. You're done. No more like terms. No more adding and subtracting because there's no more like terms. Okay. All right, number 2. What operation am I going to perform? Distributive property, multiplication, right? Distribute, distribute. So when I multiply, that's when I collect. That's when I collect powers. I'm multiplying. So I have a 1 in front. So 1 times -10. -10. I collect powers. So how many powers do I have now? 4. 1 times 1 is just +1. That one doesn't have any powers to collect. I'm done. They're not like terms, so I can't add them to make -9. And they're not, yeah, they're not like terms. Okay. Look at number 3. This one, the directions have changed. They said simplify, and then make sure your answer is in standard form when you're done. Okay. What operation do you think I'm going to do here? Add, subtract, or multiply? Multiply, yeah. Kind of looks like one we've seen before, right? I can't distribute. I can't distribute a -1 because it's got a 3x with it. So how do you think I'm going to multiply? We've used this step before. Close. Something we've used before, Manny. Yeah, that's what Ernesto said, like do distributive property. Not that kinda, but we're going to use something different. Yeah, Gio? There you go. We're going to use a box because we used that in the past. Why not use it again? We've only used 2x2 boxes, but this one's not going to be a 2x2 box. This one's going to be a 2x3 because this one's got 2 terms and this one's got 3 terms. So I need a 2x3 box. Got to build a custom box. So your box can look like this. 2 rows, 3 columns. Columns are up and down. Rows are side to side. It can look like that. That's an acceptable box. Or it can look like that's okay too. You can have a box that looks like that too. This one just has 2 columns, 3 rows. Doesn't matter which one. Up to you. Most likely you're going to choose that one. That's fine. Okay. So I might make okay. So the one with 2 terms is going to go on the side, 3x minus 1. The one with 3 terms is going to go on the top. Multiply. We've done this before. You did it on your last test. Multiply. When I multiply, that's when I collect powers. So the first one, there you go, is going to be 3 times 3, which is 9, x to the third. The next one, 4 times 3 is 12, x squared. 6 times 3 is 18, x. Okay, that's the first row. Now the next one, -1 times 3 is -3x squared. -4x and -6. Combine like terms. Let's see. This guy and this guy are like terms. This guy and this guy are like terms. When I combine like terms, I don't collect powers. I just combine like terms. Okay? So the first power, the degree is 3. So I want to put that guy first. We don't collect powers. Yeah. When I'm combining like terms, I don't collect powers. So the green is going to stay x to the second power, but I just add the coefficients. 12 plus a -3 stays squared. Same thing with the purple. I don't collect powers. So it's going to be positive 14x minus 6. You are done. There's no more like terms. It didn't say to factor or anything. You know, like it said fact. We'll get to that later in the chapter. But for right now, it's just adding, subtracting, multiplying. Okay. All right. So what I want you to do is number 4. I want you to do example number 4 right now. Look to number 4. I want you to do that one right now. Okay, so this one needs a 3x3 box. Okay. So it doesn't matter which one you put because you're multiplying, right? Order doesn't matter in multiplication. Order doesn't matter. If I give you 2 numbers, it doesn't matter which one you do first and which one you do second. You're going to multiply them. 4 times 3 is the same as 3 times 4. So if you put this guy over here and you put this guy over here, it's okay. As long as they're in order. So as long as 4x squared is with 7x and with 3, and x squared is with negative 3x and with positive 4, you're okay. All right, so now I'm going to multiply. Collect powers. 4x to the 4th. 7x to the 3rd. 3x squared. Negative 12x to the 3rd. Negative 21x squared. Negative 9x. 16x to the 4th. 28x. 12. Positive 12. One of those wrong. Good. Good. Okay. Yeah, let me know if I get use them wrong, because sometimes I make little mistakes. There you go. That I knew I did something wrong. I saw some faces that said, Mr. Flores, you did something wrong. Okay. Combine like terms. The nice thing about doing it this way is that look at all the like terms. How are the like terms all aligned? They're all aligned, right? So that's the way. That's another reason why I like doing the box, is because the like terms are always going diagonal. That's how you know if I would have known if I did something wrong when I did this, because that x to the 4th wouldn't have fit there, right? That's 16x to the 4th. It wouldn't have fit. Okay. So here we go. Big power, 4x to the 4th. Next one, I'm not collecting powers anymore. Negative 5x cubed. Negative 2x squared plus 19x plus 12. You're done. That's it. So the last thing we're going to do is I'm going to mix everything together. So now this one just had some multiplication. It had a little bit of combining like terms. The last one in the notes is kind of a combination of everything. It's got a little bit of this, a little bit of that, a little bit of this, a little bit of that, right? It's like when you go to Chipotle, you can go, I want this from this from that, this from this, that from that, right? You get to custom your order. It's the same thing, okay? Like if I go to McDonald's, I get a hamburger. I don't, it's a hamburger, right? So, but this guy is got a little bit from column A, a little bit from column B, a little bit from column C, a little bit from column D. So it's got an exponent. It's got distributive property, and it's going to have some combined like terms. So the way we're going to do this is I'm going to use Pemdas. Pemdas. Okay. I'm going to start with the P, parentheses. I do have parentheses, right? I have parentheses here, and I have parentheses in there, right? In the orange. Can I add those together inside the parentheses to make 4x? No, right? I can't do that, right? I have to keep them separately. So there's really nothing to do with the P. So the P, I checked it out. I couldn't do anything. Exponents. Exponents. I do have exponents. I have exponents, right? It's squared. What is squared? This whole guy, right? This whole x plus 4. The whole thing is being squared, right? What does squared mean? Times itself, right? Okay, so I have to do this part first. The green part I have to do first. So what I'm going to do is I'm going to go over here, because I need to do, so I'm going to take this to the side of here. Okay? Mm-hmm. What's that? Yeah, can I finish this problem? Okay? How do I multiply? What am I going to do to multiply x plus 4 and x plus 4? Because this is what it means, right? This is what it means. X plus 4 and x plus 4. I'm going to use the box. So that's why I drew the little arrow over here, because I'm going to use the box. x plus 4 and x plus 4. Okay. So over here I get x squared, 4x, 4x, 16. Combine like terms. So what I'm going to do now is I'm going to move this back. All the greens are the same. All the greens are exactly the same. Up here, they're not multiplied. Not multiplied. Over here, they are multiplied. So what I'm going to do is I'm going to move this back. Okay. Because they're the same. They're just one's multiplied, one's not multiplied. So this becomes x squared plus 8x plus 16. Everything else stays the same. Okay. So all I did was put this back. Okay. Now, no more exponents. Well, this guy's got an exponent, but x squared, I don't know what x is, so I can't really do anything. Okay, so exponent's gone. Multiplication. Do I have multiplication? Yeah, distributive property. Now I can do distributive property. Now the last step is addition, subtraction. Combine like terms. I can combine this guy and this guy. And then I can combine this guy, and this guy. So when I combine, I get plus 6. They cancel out nice and neat. Okay. All right, so I'm going to give you one more and then we'll be done. One more because there's one more type of problem. It's like number 5, except it's a little different. So I want to give you that one to give you one more practice problem. Okay. All right, so here we go. Number 6. Same directions as number 5. Same directions as number 5. So I know what some of you are looking and you're like, first thing that stands out, distributive property, right? You've been trained for a while now to see anytime you can distribute, and we will. But that's multiplication, right? We have to do parentheses and exponents first because that's Pemdas, right? So you're not wrong, but don't do distributive property until we've checked out P and E. Okay, well, again, P, x minus 2. We can't, right? We can't do anything inside the parentheses. Okay, we can't do anything inside those parentheses because x minus 2 is, they're not like terms. Okay, so parentheses is out. But I do have exponents. I do have exponents. Right here. I have to take care of those before I do distributive property. So I'm going to do one like I did. I'm going to take a side detour for a little bit because I need to multiply those two guys. X minus 2 and x minus 2. Okay, so I get x squared minus 2x minus 2x positive 4. Combine like terms. Okay, I got to move it back in. The green doesn't look the same now. So I got to move it back into where it belongs. But you notice there was a 3 out in front. That 3's still there. So I have to keep it in parentheses. Yeah, I have to keep this in parentheses. Because I haven't got to that step yet. It's going to be next, and it's coming, but I haven't got to that step yet. So it has to be in parentheses still. Okay, so just be careful with that because I know the first thing you want to do is distribute. I can't because I has an exponent. Okay, that's not following Pemdas. So now I can officially cross out the E. Now you can do exponents. Or sorry, you can do multiplication. Sorry, I said exponents, but you can do multiplication. Distributive property. Three x to the second power minus 12x plus 12 plus 3x minus 6. Okay, no more multiplication, no more division. Now addition, subtraction. So this guy and this guy. So I have 3x squared minus 9x. Twelve minus 6 is 6 plus 7 is 13. Okay. So these are the more likely to see on a test or a quiz because it has everything, right? It has every little thing. It has PEMDAS. It has exponents. It has distributive property, all of that stuff.